biostatistics, data collection and tabulation. Now, looking at data collection, this is basically the process of gathering and measuring information on variables of interest in an established systematic fashion that enables one to answer stated research questions, test a hypothesis, and evaluate outcomes. So it's more of gathering and measuring involved in the research process. The data collection component of research is common to all fields of study, including where we belong, that is health sciences, or any of the fields related which involves research. Now, at collection, we can be targeting primary data, the ones which are collected for the first time, or secondary data, the ones which we could go to records and find already used data, so that we can refine it and obtain some information of great interest. That is basically secondary data. So there's classification of data based on access and collection. Modes of data collection include personal interviews, that is one-on-one and any other, self-administered surveys, okay, use of questionnaires, literature review, direct observations, measurements, sampling, and focus groups, etc. This actually means there are many other data collection methods, but these are the main data collection modes that can be used to obtain data for processing. Now, we need to focus on accuracy as we do data collection. It is very essential for the integrity of research. If you carry out improperly collected data, then you risk inability to answer research questions accurately, or you make it very hard for a repeat or a validation of your study. Distorted findings can also result into wasted resources. Wasted resources here could simply mean that the whole money or any other things which were used for this research has gone into waste because of meaningless data or that which is collected which cannot be processed to get meaningful information. Again, what you shall conclude from improperly collected data may mislead researchers, resulting to fruitless avenues of investigation. Okay, compromising decisions for policy makers can be a result of providing improperly collected data. So policymakers will find it hard again to use your conclusions to come up with policies that are related to your field of study, and for our case, research in health sciences. Now, it can also cause harm to human participants and animal subjects. Let's imagine you've made a conclusion that something is fit for consumption, and then that is actually a conclusion made out of improperly collected data. And when some human being consume that, they end up with health problems based on this kind of improperly collected data. Now, what about tabulation in biostatistics? This is basically a systematic and logical presentation of numeric data in rows and columns to facilitate comparison and statistical analysis. The key objectives of tabulation include to simplify complex data and to bring out essential features of the data. You can have a look at the data and make some conclusion. And then there is also the ability to facilitate a comparison from a given set of data and another. You can easily make comparisons when you get tables out of them. And then one of the objectives is to facilitate analysis. Okay, it is easier to target a given data for specific analysis based on what features you have obtained from it from the tables. And this also saves space. You don't have your data scattered everywhere. You have some properly organized data in tables, and that saves space. Now, the most commonly used tabulation method in health sciences is stem and leaf plots. Okay, stem and leaf plots actually have a tendency, or the approach given is to have values which includes decimals, and whole numbers put in some table form such that the whole numbers part here, the values to the left of the decimal point, okay, the values to the left of the decimal point called stem, and the values to the right of the decimal point are called leaves. Okay, so that's the leaf and that's a stem. Now for this example we have here, the urinary concentration of lead in 15 children from an estate in micromole per 24 hours is recorded as follows. You generate a stem and leaf plot for the data. So we are going to do that generation. This is the information actually. So what we are going to do is that we are going to get two columns, that is a column for stem and one for leaf. This line here will imaginary stand for the decimal point. So we're keying in our values based on our understanding of the stem and the leaf. So for this first value, our 0 will form the stem and 6 will get to the side of the leaf. And you have to inspect your data, and during that inspection you realize that our stem ranges from 0 to 3 maximum. So that's what we have here. So you can start by listing that, so that every time you come to these values you can know which one comes first in your rows. Okay, so we have 0, 6 here. The next value is 2.6, so we'll have at 2, stem 2, you write 6 here. And 0.1, that means at 0 the next after 6 is 1. Okay, and 1.1, that is at stem 1, we'll have 1 here. Okay, next is 0.4, so we have 0, and after 6 and 1 that is 4 according to our data. Then we have 2.0, that is 2, after this 6 we have a 0, and then 0.8 still at stem 0, after 6, 1, 4, then we have 8. So and so on and so forth until you get to the last, which is 2.2. At 2 you have 2 here. So this is actually a tabulated form of this data, and you can see how it has even some good impression of what the data could contain, and you can easily tell points where we have numerous entries, at what point, and this can tell you how even the expected curve will look like if these values are plotted. So this is an example of a stem and leaf plot as commonly used in health sciences. Now the other methods of tabulation includes pictograms, that is where we use pictures, symbols to represent quantities, like what we have in this table, where we can look at the number of children who chose a given fruit. So for these fruits you can see the numbers, and this actually indicates the number of children, not really the fruits, so that a fruit can represent a child, and so on and so forth. And the other is tally diagrams. This is best for counts. Look at what we have here. Every time there's an entry or a count, you draw a line, you draw a line, you draw a line. If this is the maximum 3, that is what we have. And if you get to 4 and the 5th is supposed to be drawn in this manner, so that you get that value. 7, after this you draw others, and so on and so forth. So this is tallying, a common procedure that is used in tabulation. I hope we understood that, and our next study will be methods of data presentation, and we hope for the best. Thank you.